Hi everyone, so in today's video we're going to look at revision for smart, modern and composite materials for the second year. So just a reminder of what you need to know from last year. So first of all is what these materials were, what they do and their real life applications. Now the most common materials we needed were thermoceramics, shape memory alloys, reactive glass, LCD displays, photochromic material, thermochromic material, and then quantum tunneling composites. And then it's important that you can identify the difference between smart, modern, and composite materials. Now, I won't spend too long going through, as this is a recap of these bits so we can get onto the questions, but shape memory alloys, one of the easiest ones to remember. Hopefully you remember the video where basically you have a thin strip of metal, typically it's called nitinol, and you can distort it, bend it, twist it in any sort of way you want. Then you can either put it in hot water or give an electric current or something like that, depending on how you've done it, and it will go back to its original shape. Now, the most common uses being things like dental braces, bones, pins in broken bones. You can get glasses frames that like that are very, very expensive. But it is a really, really common smart material that's started to be used quite a lot in modern day society. So next one is your thermochromic material. Thermo obviously means heat. So this is material that changes colour in response to a change in temperature. That might be getting colder, it might be getting warmer. So the most common ones are when you see on like social media, sometimes you have like the mugs and you pour a hot drink into it or like hot water into it, and the mug will change, the patterns on the mug will change. You've also got cans, so things like on Coca-Cola, they also have it on certain beer brands where you put the can in the fridge, and actually once it's cooled down to the perfect temperature, a little pattern, a little like thing will appear on there to let you know it's like the ideal drinking temperature. You've also got it on things to do with cooking food, so you can get certain frying pans that have got like a little red dot in the middle of the pan, and that red dot will disappear when it's supposed to be the ideal cooking temperature for like a steak or whatever it is. And then it's also started to be used quite a lot in equipment for feeding young children, so bowls and spoons and things like that. So you can heat it up and then it will go a different color when it's cool enough, so it's not going to burn the child when you're trying to feed them. So next is quantum tunneling composites. So this was basically the material that comes in like normally in like a strip of like rubber-esque type of material, and what is, you got all the particles on the inside of it, and if you do nothing to it, nothing happens at all, because all the particles on the inside of it are spaced out. If you were to apply pressure to it, you close the particles together, that then means that all of the electrons can pass through it and it starts to conduct electricity. And then if you press it harder, again, they're getting closer together, it means electricity can go through more. So typically, it's quite an old material. It came around about the 90s, but it's not really been utilized until recently. So it's been used a lot more in sporting clothing because you can measure things like impact from force and things like that, which is why in things like rugby and American football, where there's like sudden impact, they can measure how hard someone's been hit, so you can measure how much damage has been done. They've started to do it a little bit in boxing gloves and MMA gloves, so you can see how hard someone's getting hit. And then in things like fencing, where if they've never watched fencing in the Olympics and someone gets a point, so you've stabbed someone and it beeps, that's because pressure's gone down, electrical current goes through. Okay, we know a point's been done. There's also potential for it to be used in touchscreens because obviously it's pressure sensitive, so you can press it a little bit to be a little bit of a button and you can press it harder to get more electricity through. So then you got thermoceramics. So this is one of the coolest ones in my opinion. Hopefully you remember the video. So it was the ceramic blocks that go into the oven to become red hot. They come out and you can pick them up almost instantly. Now the reason that is they are very, very stable at high temperatures and they disperse the heat really, really well. So they're full by combining ceramic and metallic powders at very high pressure, and they bond with each other. And what that does, it means they're very stable and strong under high pressures, whereas other ceramics will crack and crumble and other materials will just burst into flames. So they're really good in things like turbine blades for jet engines and chargers in F1 cars particularly. And it also means, though, because they're red hot, but you can go in and you can work on them while they're red hot because it disperses the heat. So that's why in F1 cars they can fix them, come into the pit lane, and do work on them. However, they are very, very brittle, so if it's to get hit, it will just shatter. They are really expensive, and because it is still ceramic, and if anyone's ever done any ceramic work in art or anything like that, if you've got little cracks in it, it is a weakness. So it's still a relatively new material, but it's got fantastic potential if they can sort of get rid of the brittleness, which you naturally have with ceramics anyway. So you got your photochromic material. So this, the most common one for this is people that got glasses or sunglasses. So they've got glasses when they're sat in a room, go outside, it's sunny, UV light comes in and it fades the lenses out. So the key with understanding what some of these materials are is looking at the first part of the word. So obviously thermo being heat, hydro being water, photo is UV light. So photochromic material means it reacts with UV light. As well as glasses, you've also got things like welding goggles. So I don't know if anyone's ever done welding before, but if you were to look directly at a welding torch while you're using it, you would end up blind, or you'd have something called arc eye, where basically it burns your retina and you're like in agony for the rest of your life. So welding goggles, if you put them on, you can see straight through them. The moment a spark comes out of your welding torch, straight away those goggles will go completely dark and protect your eyes. You then got reactive glass. So it is important to note it is different from photochromic glass. So reactive glass is glass that reacts with a little bit of an electric current. So what you have is, imagine you've got your, call it like a window, and inside that you've got all the molecules that are all lined up perfectly, horizontally and vertically. While they're all lined up perfectly, the glass is completely clear, you can see through it no problem. Once you turn the electric current off, so you turn the switch off, all of those molecules just randomly scatter around everywhere. That then makes the glass opaque so you can't see through it. So typically this is used a lot in privacy windows. In quite modern offices they use it quite a lot instead of having blinds, and they are starting to use it a little bit more in new build houses, like very expensive houses and things like conservatory roofs and things like that. It is still relatively expensive, so it's not really common, but the price is coming down, so you're starting to see it a little bit more. LCD displays, liquid crystal displays. Now what liquid crystal displays do, what the actual crystals do, is when you've got the light source from your TV, so at the back of the TV you've just got LEDs that just shine a light through your TV. Now what the liquid crystals do, is when the light comes through, the crystals force the light to twist, rotate round, depending on how much voltage is going through them, and then it blocks certain colours coming through them, depending on how it twists. And that's what lets you have different colours coming through your TV. So it's actually those liquid crystals are what causes the different colours to come through your TV to get a certain picture. Now, this is typically very commonly now in most TVs and computer screens, and that's why if you were to like hit a screen or a TV by accident and you can see light coming through, but it's because the liquid crystals have sort of been distorted and been broken a little bit, so the light twisting is sort of coming through but not going through the right filters. I will link a video that shows a really clear demonstration for doing it, but typically they are the most common way now. Any new display you're getting is going to have LCD displays for the most part. So then just a little recap of what modern smart and composite materials are. So modern materials are your existing materials that already used day to day, but they've been taken, they've been altered, and then you've improved their properties in some way to make it better. Your smart materials are materials that react to an external input, so that could be heat, light, moisture, anything like that. Then your composite is a material that comprises of two or more, so it's important you've got two or more materials together to make a brand new material to enhance their properties. So composites, so the most common composites were carbon fibre or carbon fibre and reinforced polymers. So those are used in things like racing bike frames for people on the Tour de France, or F1 cars. Glass reinforced polymers used in yachts. Tungsten carbide, most commonly for us, it'll be used in things like drill bits and cutters for millers and routers in the workshop, and they can cut through metal and diamond, and it's really hard wearing and it won't break. But you can get like jewelry that's got tungsten carbide, like the wedding ring there, and they are ridiculously expensive. They look very, very cool, but very, very, very expensive. Fiber cement, just used in construction, particularly with like tiling on roofs. And then concrete and reinforced concrete, which is obviously used in construction. So with the exam question, obviously we talked about this before a little bit, is you can't just know how to apply that particular part. It might be a question that requires you to know a little bit about smart materials, and then it'll go in and you have to join another topic to it as well. So understanding how smart materials could be applied to, and then it could give you, say, a children's toy, or it could give you utensils. So it's important that you can be able to join and mix two or more topics together to be able to answer these questions. So I'm going to go through a few of them. I'll talk you through the breakdown of it, pause the video, try and answer it, and then we'll go through the answers as well. So first one, so name a specific smart material, give an application for it. So 2 marks. So really simple for that one is 1 mark for the smart material and then 1 mark for the application. If you don't get the first part right, so if you don't name a smart material correctly, you can't get the second mark because one leads into the other. The next one is give 2 reasons to explain why the smart material is suitable for the application you have named in part A. So 4 marks for that. So 2 marks for each reason. So reason 1 gets 2 marks, reason 2 gets 2 marks. So you give 1 mark for giving the reason, and then another mark for backing that up with evidence, which is why you can never write 1 or 2 words. You've got to give your reason and then explain why your reason is correct. Now again, if you didn't get the first part right, the smart material part right, the knock-on effect is you can't get the rest of those questions right. So that's 6 marks. So pause the video, give yourself 6 minutes, answer it, unpause it, we'll go for the answer. Okay, so specific smart material, so you get anything like thermochromic pigment, that could have been baby feeding products, colour changing mugs, thermocolor kettles, anything like that. Thermochromic film, battery indicators, thermometers, photochromic pigment, phosphorescent pigment, polymorph, shape memory alloys. Any of those would have been absolutely fine as long as you know the use for it. So if we take thermochromic pigment, really easy one. If you say that was for baby feeding products like spoons or bowls, and then give 2 reasons to explain why that's useful. So you say changes colour, get 1 mark. That means you could indicate if the food is too hot or cold for a baby, gets you 2nd mark. And then another reason could be non-toxic material, fine. So then much safer to use while feeding children. So that gets you 1 mark for the smart material name, another 1 for the application, 1 mark for the reason why, and then back it up with evidence. So for example, it changes colour with heat, gets you 1 mark. Then explain what that means. So that means it will tell you if the food is too hot or too cold, gets you your 2nd mark. Okay, and reason 2, non-toxic material, 1 mark. That means it's safe to use with food products, 2nd mark. That's where the breakdown of give your reason and then back it up a little bit as well. That's how you get those extra marks. Next one, give a use for each of the following smart materials and a reason why it's suitable for that use. So nickel and titanium alloys, that's nitinol, so that is your shape memory alloy, and then your photochromic pigment. So 2 marks each, 1 mark for the use and 1 mark to back it up with a reason. Now, with these, if you don't recognise the name of the material, take an educated guess. Okay, so things like photochromic pigment. Remember that photo means it reacts with UV light. So think of a product that would use the UV light to react with it. Okay, so you always look for hints in the question if you're not 100% sure. So 4 marks, pause the video, 4 minutes, have you got your answer in it? Okay, so nitinol, dental braces, bone fixings, muscle wires, anything like that would be fine. And then reason being, reacts to heat, so it sets back in place. Photochromic pigment, sunglasses, safety visors, welding goggles, anything like that. Photochromic pigment reacts with UV light to shade out and protect the user, would be fine. So next one, carbon fibre reinforced polymers and glass fibre reinforced polymers are examples of what type of material. Give an application for one of the materials named in part A. Give 2 reasons to explain where the material is suitable for the application you've given in part B. So first part is 1 mark, the second part is 1 mark, and the next one is 4 marks. It's similar to the question we've just done. So it's another example of an instance where each part of the question leads on to the next part. So make sure you read the whole question first. Don't just start straight away when you're answering it and go A. It's good to read through the whole question first so you can see where it's leading to, and then have a go at answering it. So I'm not going to give you a breakdown of it. Pause it. So you got 4, 5, 6 marks. 6 marks, 6 minutes. Pause it, have a go. Okay, so carbon fiber reinforced polymer or glass reinforced polymer, the type of composite is your mark. Give an explanation for the materials used: canoes, boats, racing cars, sporting equipment, tennis rackets, golf clubs, anything like that. And then give 2 reasons to explain why the material is suitable. So you can be done in a range of colours, it can be manufactured into complex shapes, it is chemically resistant, it will not corrode, it's a very tough material, it's very good strength to weight ratio, anything like that. So obviously it depends on the material, the application you chose. So if you chose something like, say, a tennis racket, you would then say, well, it's lightweight, maybe 1, because obviously you don't want a tennis racket that's going to be too heavy, and then it's tough, so it can withstand impacts, so it won't shatter when someone makes contact with the ball. If you chose like an F1 car, again you could say, okay, it is lightweight and it is heat resistant, so it's not going to react when the cars get too hot. So it's all about making sure you select the right answer to begin with. So next one is, sometimes it's necessary to combine 2 or more materials in order that the enhanced properties can be utilised. For 2 of the following, name a specific composite material stating its constituent parts. In each case, explain why the composite material is suitable for a specific application. So, fibre reinforced composite, particle based composite, sheet based composite. Okay, so you're only doing it for 2 of those. So if you have a look, so it's 60 marks in total, so you're only answering for 2, so realistically each one of those you need to have 8 marks for. Okay, so you have to name a suitable composite material, explaining its parts and what it's made up from, and then explain why it's suitable for its specific application. So if you've got 8 marks, let's take fibre reinforced composites. So we need to get 8 marks from that. Okay, so you've got to state what parts it's made from, so that'll get you 2 marks. You've got to name that, so we've got another 6 marks to get. And then you've got to say why it's suitable. So you then give the use for it, will give you another mark. So we've got 5 marks left to get. So then you need to have 5 reasons why it would be suitable. Okay, so 16 marks. Pause the video, give you 16 minutes, try and answer those, and we'll go through the answer. Okay, so obviously at 16 marks is one of the higher point questions you're going to get. We don't tend to get 60 mark questions on the new specification, but it's important to have a look at because we will get 15 mark ones. So we take fibre reinforced composites. So fibres such as glass and carbon are used to reinforce polyester and epoxy resins together. So that's first of all naming the correct one, and then that is telling you what it's made from. That is your 2 marks. Then your uses, so aerospace, automotive, marine applications. Okay, things like racing or sports cars, F1 cars, canoes, speedboats, motorcycle helmets, anything like that. If you take your particle-based boards, you've got things like concrete, which is made from aggregates, stone, cement, and sand. Typically used in construction, building, bridges, garden ornaments. You've got cements, which is metals, and ceramic particles, which would be things like tungsten carbide for very sharp cutting tools. And then sheet-based, so plywood, blockboard, chipboard, MDF, they're all particle-based composites, typically used in furniture and building construction. MDF or chipboard may be accepted as particle board as well, so you could say particle board. Or you could add nitinol, which is like nickel and titanium. So that's first of all just telling you examples of it and then what it's made from. So in order to get the higher marks, so you need to precision and accurately naming the materials, provide both the details of what it is and then why it's suitable. So what I've given you at the top in red is an example of it and then what it could be used for. You've then got to come up with the properties that make that more appropriate. Okay, remember, so for each one, so you're only answering 2 of the 3, so you've got 8 marks to get. Okay, so I've given you the first bit that gives you the first 3 marks. So now you need the 5 other marks for the reasons why, and that will be the properties of why it's acceptable. Now that might be because it is chemical resistant, that means that it is relatively cheap, that means it has got good tensile strength or good compressive strength. It could be that it's easy to form into other shapes through molding, or it's easy to cut down size in specific tools. So anything like that, as long as it's appropriate to the right one. Okay, so that is the end of smart materials. If you need to go over some of the original content before, the video for the first year content is up as well with some video examples. And if you've got any questions, please do send me a message.